Today let's talk about Thevenin equivalency. So we have our circuit here. This is going to be a simple example here, something you might find in an introductory circuit course. So we have our two voltage sources, 28 volts and 7 volts. We have our circuit here. We have two voltage sources and 3 resistors. R2 here is going to be our load resistor, and that's going to be important because we're going to remove the load resistor and break up the circuit here. Let's try and find the Thevenin voltage, VTH, of the circuit. That's going to be the voltage going across this gap. Let's set up a table and try and figure it out. Okay, so we have our table set up. Let's fill it in with what we know. So R1 is 4 ohms, R3 is 1 ohm, giving us a total of 5 ohms. The voltage drop in the circuit is going to be 28 volts minus 7 volts, giving us 21 volts. So that's going to be our total voltage in the circuit. Now let's find current. In order to find the total current, we are going to need total voltage over total resistance. So our total voltage is 21 volts and our total resistance is 5 ohms. That's going to give us 4.2 amps. So that's going to be our total current, and that's going to be our current across each resistor. Now let's find the voltage across R1. For that, we're going to need current through R1 times the value of R1. This is just Ohm's law. V is equal to IR. So we know the current, 4.2 amps, and we know our R1 value times 4, and this is going to give us 16.8 volts. And for R3, the voltage across R3 is going to be current through R3 times R3. So we have 4.2 amps times 1 ohm. That's just going to give us 4.2 volts. So we have all of our values for the table. Now that we know the current through all the resistors, now we can calculate the voltage across this open node here. The voltage between these 2 points can be figured out from either side's voltage and the nearest resistor's voltage drop. So if we take this side, for example, we have V1 minus the voltage drop, which is just the 16.8 volts that we found. That's going to give us our Thevenin voltage. So 28 volts minus 16.8 volts is going to be 11.2 volts. We can do the same on this side. So we have our V2 value as 7 volts. And on this side, we're going to want a plus. We're going to want to add these two. And that's because if we look at the circuits, we do some analysis here. We're going to have our signs set up like this. This will be negative. This will be positive, this will be negative, and this will be positive. So if you look at the circuit and kind of think about it, you'll see that we have 7 volts plus 4.2, and that's going to give us, let's see, 7, 8, 9, 10, 11, 11.2 volts as well. So that's our Thevenin voltage. Now let's see if we can find the Thevenin resistance. In order to find this, let's go ahead and ignore our voltage sources and just focus on the resistors. So in order to find the Thevenin resistance, this is the formula we're going to need for this type of circuit. 1 over R1 plus 1 over R3. That gives us 1 over 1/4 plus 1 over 1, which is just 1. And that gives us 0.8 ohms. So the resistance between these 2 points is going to be 0.8 ohms. Now let's construct the Thevenin equivalent circuit. So we know our Thevenin voltage was 11.2 volts. Our Thevenin resistance was 0.8 ohms. And our original load resistance was 2 ohms. So we're left with here a simple series circuit. Makes it a little bit easier to analyze than the original circuit we had prior. Now we can look at trying to calculate the load current and the voltage drop across the resistor with another table. So here's our table. Let's try to find well, first let's fill in what we know. Our Thevenin resistance is 0.8 ohms. Our Thevenin voltage is 11.2 volts. Let's find our current. So the current is just going to be V over R. So our voltage is 11.2 and our resistance total is 2.8, giving us our current 4 amps. So we have 4 amps here and we have 4 amps all across the board. And we also know that obviously our load resistance is 2, making our total 2.8. Okay, so now let's find the voltage drop across our equivalent resistor here. So our VR Thevenin is going to be equal to our current times our resistance. So 4 amps times 0.8 gives us 3.2 volts. Now let's find the voltage drop across our load resistor. So we'll go right here. VR load is equal to our current times our load. And that's just 4 amps times 2 ohms. Gives us 8 volts. And there you go. That was just a quick example on how to kind of go through and use Thevenin's theorem to simplify a circuit. This is great when you're doing circuit analysis. It can take a big circuit that you're working with, a big messy circuit, and kind of reduce it down and make it a little bit easier, less of a headache on you. Hope you enjoyed. Thank you for watching.